Many developers and DBAs came across a situation where a server became ill-equipped to handle daily workloads. In such situations, people usually turn to sharding, but what does sharding mean and why is it important? Sharding, simply put, is a method of distributing data across multiple servers. Sharding is necessary when data becomes big enough and your server starts facing challenges related to data and throughput. Sharding in MongoDB is supported by horizontal scaling. Horizontal scaling splits the load of the server across multiple servers, thus reducing the load on a single server. That way, a single server handles only a part of the workload. Horizontal scaling increases complexity in managing the infrastructure, but at the same time comes with lower cost and high-end hardware for a single machine. A sharded MongoDB deployment is often referred to as a sharded MongoDB cluster. Each sharded cluster contains three components. A shard that contains a subset of the sharded data, a query router called Mongos, and configuration servers that store metadata and configuration settings related to the database cluster. For a sharded cluster, MongoDB recommends using a cluster of MongoDB servers that are capable of implementing replication and automated failover. Each server cluster is known as a replica set, and a sharded cluster will most likely be deployed by deploying config servers, and each shard is a 3-member replica set. Additionally, one would need to deploy one or more Mongoose routers. It is also recommended to deploy at least one member of the replica set in a location that is suitable to be used for disaster recovery. As far as the number of database shards is concerned, MongoDB recommends using at least 2 shards for sharded data distribution. When it comes to Mongoose, one should either embed the routers at the application level or add a Mongoose instances on the same hardware where other Mongoose instances are running. If you use a proxy or load balancer in between the application and the Mongoose routers, configure it for client affinity to allow every connection from a single client to reach the same Mongoose routers. Client affinity refers to a consistent client connection to a specified data source. You can see a common sharded cluster architecture shown on your screen right now. For demo deployments, MongoDB recommends using a sharded cluster with a minimum number of components, these being a Mongoose instance, a single sharded replica set, and a replica set configuration server. An example of such a deployment can be seen on your screen as well. Do you use the sharding features provided by MongoDB? Share your thoughts in the comment section, and until next time.